Hello lovies, this is lesson 92. It's on random assignment. Where we're coming from is experiments and confounding. So we have just talked about how the biggest distinction between sampling and experiments is that sampling has random selection. So you randomly select the individuals in your sample. Whereas an experiment has random assignment, meaning you randomly assign individuals to a treatment group. The difference between random selection and random assignment allows us to show causation. So if we randomly assign a treatment, we can show causation. If we do not, then oftentimes what happens is we have a confounding variable. So we can't say for sure if one thing caused another. We can only acknowledge that there is a relationship or an association. So if random assignment is so important, then obviously we're going to need to know how to randomly assign our individuals to a treatment group. As usual, we're going to discuss this process in context of an example. So a high school has enough budget money to compare the online SAT course with the classroom SAT course. 50 students have agreed to participate in an experiment comparing the two instructional methods. Maybe you've been noticing that as we've started talking about or having more examples of experiments, how these problems typically start is by the prompt telling us that we have some individuals that volunteer to be in our experiment. And that's okay. So when we're sampling, we want to randomly select our sample. But when we're talking about experiments, we have to have volunteers. If we're going to impose a treatment, if we're going to assign people to a treatment group, then we really need to be working with people that know that they're participating in an experiment and are okay with them getting a treatment. So it's okay that these 50 students have agreed to participate because we are going to randomly assign them, sad day, to a treatment group. So it starts with two-hat method, but really, after I taught this to the B days, I realized that what probably would be better is to start with the most basic method of random assignment. So this is the very back of your experiments packet, and I would highly recommend that you write this down. So this is a basic random assignment with hat method. This is going to sound very similar to random selection. So number one, we're going to write the names of those 50 students on identical slips of paper. 2, we're going to put them in a hat. 3, we're going to shake the hat to randomize. 4, we're going to pull slips out one at a time until we have 25 slips. Why? Well, we have 50 people in our 50 available people, I should say, so N, and we're going to divide that by the number of treatments. So that's 2. That's going to tell me how many people I need to put in each treatment. So this 25 that I'm getting here comes from N divided by the number of treatments. You can use that always. When we have something more simple like 50 students that we're going to split into 2 groups, the number in each group seems very straightforward, but once we include more treatments, we're going to want to remember this. Your sample size divided by your number of treatments. So 50 divided by 2 is what gives us the 25 slips. The students that match the numbers on the 25 slips you pulled out will be assigned to the classroom course. The remaining 25 students will be assigned to the online course. And it's important to note here that I chose the classroom course. I chose that, and I made that one first simply because of alphabetical order. C comes before O, so of the two treatments, I just went, oh, I'll assign the first one in alphabetical order to the first 25 kids that come out of the hat. So this is basic hat method. Two takeaways, so I just want to highlight those real quick, and then we'll talk about technology. Number one, so the students that match the 25 slips you pulled out will be assigned to classroom course, then online course, so classroom first, then online, because alphabetical order. So that's the first, one of the first things to note. You don't have to do it that way. You could have assigned to the online first because that's the first one that's in the prompt. So in the prompt it says, we're going to compare the online course with the classroom course. So maybe you want to assign the online students first. Then the other thing is when you are calculating the number of people in each treatment group, you want to use this formula. So 25 comes from that formula. So basic random assignment, the most basic way to randomly assign. Now let's look at this with technology. It is very similar. So describe how you would use technology to randomly assign the students. So, step number one. So I am skipping to hat method and I'm going to go to technology. Step number one is label each student that agreed to participate with a unique 2-digit number from 01 to 50. Is this, I'm lying, a unique integer? It's getting a little ahead of myself. Unique integer from just 1 to 50. I will use my calculator to randomly assign each student to an instructional method. That's the same thing as treatment group. Instructional method is the same thing as treatment group. And then I want you to notice there's asterisks here. We're going to come back to those asterisks after we finish this. So, I will use my calculator to randomly assign each student to a treatment group. So I'm going to write the buttons that I actually push based off of the calculator I use. So if you use the newer model, this is going to be slightly different for you. I do math. I arrow over to probability. I choose option 8. Which is rand, int, no, repeat. My lower bound is 1, my upper bound is 50. If you have the newer one, you are going to say lower bound 1, upper bound 50, n equals 25. I will assign those students to whatever treatment group you choose. For me, I have to say the students that match the first 25 integers listed will be assigned to the, sorry guys, I ran out of space. So the students that match the first 25 integers listed will be assigned to the classroom course. The remaining 25 students will be assigned to the online course. So this, it mirrors or is the same process as this. This is HAT method. This is technology. Now we're going to complicate it a little bit more. So I had us note these asterisks because we're going to make this random assignment even better now. So I chose in the past 2 examples to assign based off of alphabetical order. So my first 25 went to the classroom, my second 25 went online. It would be a better design if I randomized that as well, if I randomized which treatment got assigned first. So one way to do that in this particular example is to flip a coin. So where these asterisks are, what I could have written instead is, I will use my calculator to randomly assign each student to an instructional method, and I will flip a coin to determine which treatment is assigned first. Then I would add in these asterisks. Sorry if you couldn't see that. I will use my calculator to randomly assign each student to an instructional method, and I will flip a coin to determine which treatment is assigned first, or which instructional method is assigned first. So remember, treatment and instructional method are the same thing. So these bullet points here would be inserted here. So this little mark here says, hey, put these here. So the steps for that, you could use a coin to randomly determine which instructional method will be assigned first. Let heads be the classroom course and tails be the online course. Flip the coin. The method that matches the side facing up will be assigned first. So I'm randomizing both elements of this experiment. I'm just seeing if I have a coin laying right next to me so I could actually flip one. So I'm randomizing the students and I'm randomizing the treatment that gets assigned first. When you do this, when you randomize what treatment is assigned first, what you have is a completely randomized design. This makes it a completely randomized design. this portion without the elements in blue is just random assignment. So just like on the back of our note sheet, I specifically have random assignment. This is just randomly assign the students to a treatment group. Completely randomized design is something different. It's when you randomize all elements that can be randomized. So I'm using calculator to assign the kids, a coin to decide what to assign first. You don't have to use a coin. You could have said, I will use my calculator to randomly assign each student an instructional method and determine which instructional method to assign first. You would then have to say, let classroom course be 1, let online course be 2, and then use your calculator to randomly generate a number from 1 to 2 or 1 or 2. So you don't have to flip a coin. You can use your calculator for both parts. For the coin part, you would do rand int no repeat 1, 2. So maybe I should add that in. I'm going to pause and add that in and give you the option to add that as well if you would like. Okay, so I added it in here. If you wanted to use your calculator instead, I just said 1 equals the classroom, 2 equals online, rand int no repeat 1, 2. The method that matches the first number generated will be assigned first. So, completely randomized design. You randomize the students that get assigned first and the treatment that gets assigned first. There's one other element that we needed to add in, and it's what would we say after we generate the students. So for a completely randomized design, what you would say here is the students that match the first 25 integers listed will be assigned to the course determined by the coin or calculator. So the first 25 will be assigned to the course determined by my calculator or by the coin. The remaining 25 students will be assigned to the other course. So everything I added in blue makes it completely randomized. There's a better way to do this. Hopefully you're thinking, this is so extra, because it is. The easiest way to do completely randomized design is 2-hat method. So up here, 2-hat method is the easiest way to have a completely randomized design. So 1-hat method allows you to assign the students to a treatment group. 2-hat method allows you to assign the treatment and randomize what treatment gets assigned at the same time. So how would we do this? Number 1, we would write the names of the 50 students on identical slips of paper and put them in a hat. On 25 identical slips of paper, write classroom, and on another 25 identical slips of paper, write online. Where am I getting this 25 from again? Your sample size divided by your number of treatments. Put them in a second hat. So in 1 hat, put all the names. In the second hat, put 25 slips that say classroom, 25 slips that say online. Shake each hat to randomize. Pull one slip of paper out of each hat. The student from slip 1 will be assigned to the treatment on slip 2. And remember, treatment is the same thing as instructional method. Repeat until all 50 students have been assigned to a group. So much easier than using technology. So there are 50 slips in each hat. For the students, it's their names. For the treatments, it's 25 with each treatment group. So completely randomized. Completely randomized. Not completely randomized. And it's okay. This is still a good method. It's just not completely randomized. The last one that we're going to do, as it is written, is not completely randomized. So that is assigning using random digits. I'm going to go through this one pretty quickly because it's like almost the exact same bullet points from the notes on using a random digit table. So number 1, label each student with a unique 2-digit number. Begin with 0, 1 and end with 50. I will use my calculator to randomly select a starting line on table D. So I would do rand int no rep starting line 101, ending line 135. If I have my calculator here, I'll do that real quick. So on the table that I gave you guys, that doesn't look good. Your table starts at 101 and goes to 135. So math, probability, 8, 1, 101, 135, 1. So I would start on line 127. So starting from line 127, I will mark consecutive 2-digit numbers moving from left to right. I will circle 2-digit numbers used to label the population, so 0, 1 to 50. I will cross out repeats. I will cross out 2-digit numbers that were not used to label, so that would be 0, 0, 51 to 99. I will stop marking numbers when I have circled 25 2-digit numbers. The students that match the 25 numbers circled will be assigned to the classroom course. And notice the asterisks are here again, because if you want it to be completely randomized, you have to randomly decide what to assign first. The remaining 25 students will be assigned to the online course. So this, as it is written, is not completely randomized. So I think I'll write that at the top. As written, not completely randomized, as written. So biggest takeaway for me is that if they ask me to completely randomize anything, I'm doing two-hat method, which leads well into the check for understanding at the bottom of this page, or right underneath what we just finished. So in an experiment to determine how calories affect appetite, researchers randomly assign volunteers to one of 4 treatments: 150 calories of apple slices, 150 calories of applesauce, then apple juice with fiber. 15 minutes later, the researchers will provide each participant with a large bowl of pasta and measure how many calories they consume. Set up a completely randomized design. So I am going to do two-hat method because for me it's the easiest. Before I start, I just want to get all of my basic information listed. So there are N participants. Unfortunately, they did not tell us how many people are participating. We have 4 treatment groups. So there will be N divided by 4 participants in each treatment group. N participants and 4 treatment groups, so there will be N divided by 4 participants in each treatment group. So one way to think about this is the following, and you do not need to write this down. Let's say that there are 200 participants. Well, N divided by 4 would give us 50, which means 50 people would be in each treatment group. So don't let the N divided by 4 confuse you. You know what that means. I have it drawn here very sloppily, and there isn't 200. I just wanted to use a number so that it made more sense where that N divided by 4 was coming from. So that being said, let's list out what we would do for two-hat method. So first thing, write the names of all the participants on identical slips of paper and put them in a hat. On N divided by 4, identical slips of paper, write apple slices. Repeat for apple. Repeat for the treatments. Apple sauce, apple juice, and apple juice with fiber. Put these N slips in another hat. So I'm indicating that each treatment gets N divided by 4, and when I put them in the hat, there will be N total slips. Shake each hat to randomize. Pull out one slip from each hat. The participant on one slip will be assigned to the treatment on the other slip. Repeat until all N participants have been assigned. Now pause if you're not done, and then unpause when you're ready. So this is completely randomized. If they wouldn't have explicitly said completely randomized, you could have just done one hat method. So just hat method. You could have said, write the names of all the participants on identical slips of paper, shake the hat to randomize, pull out slips one at a time until you have N divided by 4 slips. Those participants will be assigned to the applesauce group. The next 25 will be assigned to the applesauce group, the next 25 to apple juice, the next 25 to apple juice with fiber, because I'm just going in the order that they give it to me in the prompt. So you don't have to use 2 hat method unless they say completely randomized design. You could just use hat method. Just depends on which one you want to do. So now that we've gone through all that, and our knuckles are broken because of so much writing, your last check for understanding is assigning the treatment groups for number 2, and they want you to do it all the ways. So using slips of paper, which means hat method, using technology, and using table D. Notice that all they're saying is describe how you would randomly assign, which means you do not have to do a completely randomized design. You can just randomize how you assign the students. You don't have to randomize which treatment they get. You don't have to randomize which treatment gets assigned first. If you're confused about what I'm even saying, make sure that you ask me. Okay? Because this is saying you can use hat method if you want to, and there's a difference between hat method and 2 hat method. So make sure you know those differences. The last thing that I wanted to say is, if you would prefer to type this up, because it kind of is a lot of writing, if you want to type it up, feel free to do that, and just like attach that here, like tape it in or something. You're welcome to do that. I think I'm going to type mine up when I show you my solutions. Okay, that's it. Love you guys.